Hi everyone, once again welcome to this lecture. Again the class is the programming class. Today we will be continuing our discussion on Tickle. So last time we saw we actually went through a set of commands, basically the list commands, the string commands, global expressions, actually it's a regular expression, then the globbing style operation essentially, or globbing style matching, and also we talked about the exact matching using the string commands. These are all they all fall under the string basically. And then we also looked at the glob command, which is actually different from this globbing style. And then we also looked at scan and format commands for reading in information and also like formatting the outputs. Then we went into the control structures, essentially like while loop, if loop, all those things we looked at, for loops and things like that. So the key thing about Tickle is, again I want to re-emphasize, this is the first lecture that we did. Tickle has two parts. There is a interpreter and then there's a parser. So as you all know, Tickle is nothing but set of words separated by white space, and it's also like separated by the new line characters, or every line. Every line is detected as one command, each line of Tickle script. Otherwise, like the command delimiter is a semicolon. So anything that is either a semicolon or a new line character is treated as one command, and then that command is again further split into white spaces, basically like, so each word is split by white space, and then that particular command is sent to the parser. So interpreter itself does not play any part in understanding whether it's a command, whether it's an argument, things like that. Once it passes all the words to the parser, then it's the parser's job to understand, okay, the first word is interpreted as a command, this is the command, and then once the command is interpreted, then it actually like now looks at all these arguments. So for each command it knows like how many arguments. So once it understands that there is a command, that's when the arguments are decided, and that's when it actually like goes through in detail as to what exactly is each command can do and how many arguments does it take, whether you filled out all the arguments or not, and things like that. So this concept is very important because this is how we will be writing our programs and examining them. So this will help you in debugging the programs. Again, you can avoid like a lot of common mistakes if you understand this structure, and this is how things will be done. Once you understand this, then you can avoid a lot of issues. Okay, so just looking at simple programming, actually like there will be like more examples that will be in your labs. So this is a quick program to generate a random number. Can anyone tell what exactly it does? There are like different things basically. One, I want to draw some attention to the first lecture and the second lecture actually, especially the second lecture where we talked about two major things. One is the command substitution, and then the variable substitution. So this is command substitution, variable substitution. So in this one, in this particular command, at least like there is that one thing is happening, which is command substitution. If you look at the square brackets here, so anything within that one, that square bracket is um, interpreted as a command. So here we have this command. So the Perl, I mean sorry, the Tickle interpreter, when it goes through this, it separates it out basically like a set random number, and then it substitutes this command, and then basically like so once this is again recursively called. So and it goes to the parser. Now the expr has been parsed, and it knows that it's a command, and that needs certain arguments. So here we have an int rand, and then with nothing, and then times 10. So now here we don't need that. So it knows that actually like this argument is int rand with just parenthesis. So this rand is further called as a function, and that rand is actually defined as rand will get a value, a random number between 0 and 1. So that's what this returns, and surely enough 0 and between 0 and 1 it's actually it's like some it's not an integer, it's just a value. Basically it's a floating point number. Now that gets multiplied by 10, so that gives you a number between 0 and 10 now, and this number can be a floating number, and then now the integer is applied on top of it, and which converts this number into a regular integer between 0 and 10, and then that's how this expression is evaluated, and that's assigned to this random number. So the random number actually equals random number is any number between 0 and 10, and it's an integer. So I hope like this is simple example, but it has enough complexity in it to explain how this works. So now that we are seeing this this example, this actually sets the topic for today, which is essentially the tickle procedures. So we will cover a number of things in the tickle procedure today, and this is probably the most important thing to learn and understand in tickle. So let's look at the procedure. So before I go that, in tickle pretty much like all the programming is developed as procedures, and then basically like the top level program will just call these procedures for to get the values essentially. So if you look at the Perl programming language, we had functions that pretty much did a lot of these things, but here it's the procedures. So how do we define a procedure? That's the first thing. So first we put this keyword called proc, and then the next word is the name of the procedure, and then we have list of argument names, then the body. So a proc command, how many arguments does it take? If you look at here, we have sub 1, this is argument number 1, this is argument number 2, and here we have at least 2 different words. But if you look at this, the curly braces, this makes it into a single word, as we know, and this is the third argument. So a proc command will take 3 arguments, the first being the name of the proc, the second being the list of arguments, and then the third is the body of the proc. So I want you to remember these things basically so that you can um, easily identify a tickle script and easily identify parts of the tickle script, and also you can understand what exactly the script is trying to do. And procedures behave just like built-in commands. So here basically here we have the same thing basically with an argument of 3, and then that gives 2. Basically sub1 3 gives the value as 2. And then the arguments can also have default values. For example, but again they are all like in just one word. So we will be putting a lot of these curly braces. For example, here the proc BCR, this has again like after proc it is 1, 2, and 3. But if you look at the second one, we have not just one variable, we have one variable here and one variable here. There are 2 arguments to it. And then the first argument does not have any default value. The second argument has a default value of 1. And then the expression is basically like $x minus $y, which is this x minus this y. That's what is will be passed back to the program that calls this procedure. So fairly simple. We will introduce some more additional concepts later on, which is the proc arguments and or proc attributes and things like that. We don't want to impose on you with all those other details, the complex details. Simply put, you have a procedure with essentially all you got to remember is the proc statement or proc command has 3 arguments. The first argument being the name, second argument the arguments, and then the third one is the body of the procedure. So now let's look at a procedure. So here we have a top level which sets I as 0, and then we call the procedure F where we set I to 2. Again, once we do this, it's not okay. Why is that not okay? Because we have defined already I here, but if you use it inside the procedure, what happens? The second one is now like if it's 1, then set J is 0, and then increment J. Increment J, even though like we are setting J as 0, this is okay. Why is this okay? So in procedures and in tickle in general, there is a concept of scoping, which is what we will talk about in great detail today. The scoping is essentially to understand what is the life of a variable. For example, here the life of the variable is only up to here. So when you go here, it cannot be. This is a different procedure. Procedure starts, and then this is a variable that is already here. So tickle will be erroring out. Whereas here the J scope is all the way to the end of the procedure. It starts here and goes all the way to the end of the procedure. So if you increment J, this is okay. So this is okay. This is not okay. That's because I does not have the scope into the procedure, and we are using it something which is not defined. So now the first question is, how do we get I into this program? Can we do something so that the program recognizes I and actually moves forward? One quick way to do it is put it in the argument, right? Which is what you can do essentially, and then once it is in the argument, then you can, it's a fair game as to like what you're going to do with it. and then you can return it. But oftentimes we won't be able to do it, and so SQL actually provides some rich command set. So again, the main thing is there are local and global variables, and the interpreter knows variables by their name and the scope. Each procedure introduces a new scope. So the scope is what was making the one that is not able to read. So here is another example, which is very similar to the previous one that we saw. We set x to 10, and then we say like the procedure is set x expression $x minus $d. Here it's even more severe. Now we are using this x, setting the x outside the procedure and using it inside. This is also not allowed. So if you try to run the program with delta x equal to delta x 1, it will just come up with an error message saying that cannot be x, no such variable. So how do we correct this issue? So Tickle actually supports another syntax called the global. Once we specify the global, then automatically the scope is transferred into that procedure as well. So if you say proc delta x b, and then immediately say global x, and then you do the set x expression $x minus $d, it understands, and then now it comes up with the correct answer, which is delta x 1 equal to 9. Because this particular one is actually just subtracting the number from number 10. Okay, and the global itself is an ordinary command essentially. I mean, it is governed by its own command names. So global is a command actually. It's not a syntax specified in the language. So again, I want to make the distinction again and again. Again, the global here. If you say now var name, and then that's what you are declaring here as global, then we set the variable name, the $variable name, to passing by reference essentially. So this is a tricky one where you can see that actually it's an ordinary command where you are actually passing the same thing basically into that command, and then you are actually also like setting that variable name like to the dollar variable name as passing by reference. So to do like some of these things where you can actually pass now the variable or pass the scope which is defined inside the procedure to outside the procedure. So the global is pretty much, it takes the scope from outside into inside proc. Now how do we communicate inside proc to outside? Oftentimes we may want to increment based on a procedure some global name or even like a local name which we need to pass it to another one. So for this actually we have two commands which are upward and up level. So the level naming is another one basically. So the top level is named as 0, and then the 0 is actually also global, and then 1 is just one call deep, 2 is 2 call deep, etc., etc. So what that means is if you have a top level and then you have a proc A, actually use the proper notation of A with whatever the arguments, and then inside the body you have proc B, and then inside proc B you have proc C, and then you close it. So this kind of scenario actually from the top level. So when it enters proc A, that's level 1, proc B is level 2, and proc C is level 3. Okay. So here there is one more example, which is 0 is current, 1 is caller, 2 is caller's caller, etc., etc. So here is one simple thing, basically like a procedure where we have increment var name. We say up var 1 var name var, and then set var equals var plus 1. So there is a tie up now between var name and var from outside, and all you got to do is if you increment, it automatically gets updated. So what does up level do? Up level does for the code what upward does for the variables. So in upward, essentially we are sending like the variable name to other procedures, whether it is higher or lower in the hierarchy. Whereas in the up level, you're actually now transferring code to the other levels essentially. So how do we do it? Essentially, here is one quick example. The procedure called loop from to script. Again, how many arguments are there for the proc? It's 1, 2, 3, and 4. I mean, actually not only 1. It's 1, 2, and 3. So that's always the same. Now, if you look at from to script, that's another command. So essentially, like I mean, it's basically we take the I from $from, and then that I to 2 we'll do like up level the script and then increment I. So here again, like I mean, the script is sent to the next level. So here as an example, set S is empty, and then loop 15 set S is $S star, and then puts $S. It puts these actually this is loop 1 through 5, so 5 stars it generates. Now, how do we capture variable length argument lists? Oftentimes it's not a fixed length, so you need to capture the variable length. So here there's a quick example. The name is sum. There are arguments, and then basically the body is shown all the way here. And then inside we say like set x is equal to 0, and then for each I args increment s by 1, and then return s. So first argument is 1, so it increments only once. Then the second argument is 2, then it increments twice, and then it basically computes the sum of all the integers that you specify from and to. So sum 1, 2, 3, 4, 5 becomes 15. Sum is just 0. So again, this args is another keyword that we will use to capture a variable length argument list. So whenever we say args, that means that the interpreter already assumes that okay, there will be like not 1 but more than 1, which will come. Okay. Now let's look at some of the error handling. Errors do occur, and they normally abort the commands in progress, and then the application will display an error message. So here a quick example, basically there is no like $I or $I here. So we set this expression and then basically the expression has an error. So here it is easy to spot this error and then correct it. Sometimes you have to look into the particular error and look for more information. So one way to get more information is this set error info, which provides more information regarding what went wrong. So here you can see basically like there's a syntax error in this expression that we wanted to be actually put together for testing, and then and it also says basically like it's a syntax error in this expression while executing exp of this, and it is invoked within which command it's getting invoked from. And look at how the command is represented here. It's actually the complete command. There's this one here, and then it also indicates the for each body line, essentially like from where this one is called. So there are some advanced error handling features. So there is a global variable already declared for you. It's called error code that holds the machine readable information about errors. But it can interpret errors and then it can do some exception handling. So for example here there is a simple one which is catch expr2 plus message. So the catch returns 0 for OK and then 1 for error. And then you can say like set message for getting the message, and then that now gives you the syntax error in expression 2 plus. And then the other one is like using these commands you can generate errors by yourself. For example, you can say like error, what is the error, and then you can have like a return as a code error and with bad argument. Now let's look at some of the IO files. We will have like few more items on the procedures which I'll plan to do it next time. So file IO commands, essentially there are many of them. One is open, get, seek, flush, glob, use, read, tell, cd, fconfigure, fblog, file event, puts, source, eof, pwd, and clock name. So all these are file IO commands. Actually the file name. So the file commands use tokens to refer to files. So here we're opening myfile.txt that gives back this token file 4, and so that you can use that as in further usage. So here like we can say like $f, write the text into file, so this gets printed out into myfile.txt. And then finally once you are done we just close the file handle or the token, which is just close the $f. Now the other commands gets and puts, basically they are line oriented. So when we say like gets $f, it reads one line of $f into X. The read command can read specific number of bytes, so we can say like read only the 100 bytes from the file $f. Then seek, tell, and read can do random access of IO, so they can go into a particular sector and then read from there, things like that. So here we just say like set F is open database R in read only mode, and then we do a seek basically of the 1024th element, and then we can read from the 100th. Actually this should be 1123. So we can read all the way up to that much. Actually, sorry, this is actually 100 because this is in the number of bytes. So read $f100 reads 100 bytes starting at 1024. So that becomes 1123. Final ending of where the file will be. So that's what is shown here. So there are some nifty commands within Tickle that can help you with further processing of file. Here, for example, we open a file called log with read only access, and then we can actually do file event as a command basically, and then we can say like if $f is readable, then we can do certain things basically. So the file event is such a command which is useful to you can watch the file without actually getting involved. But there are some issues. I don't know whether this is already addressed or not. You can try it out and then see whether these issues are addressed in your machines. Then there are two other commands: the fblock and fconfigure that gives you the full control over these files. So fconfigure minus buffering. It's basically like you can say line full, and then fconfigure minus blocking, you can make it true or false. Fconfigure minus translation is another command, and then fblock typically returns the boolean. Hey Sandeep. Hey Sandeep.